Welcome to our webinar on the importance of energy efficiency and sustainability. My name is Kathy Spinazi, and I will be presenting today. Energy is one of the most important resources that we have. By focusing on reducing energy consumption and minimizing waste, we not only save money by lowering our operational costs, we are contributing to environmental conservation, and that's corporate social responsibility. So in this webinar, we're going to cover the importance of energy efficiency and sustainability, optimized resource utilization, energy efficient equipment and technologies, integration of renewable energy, predictive maintenance for energy systems, data analytics for energy management, case studies, and success stories. But first, I want to share a little about who we are. ICP DAS was established in 1993 in Hsinchu, Taiwan. Later, ICP DAS USA was launched in 2001. The benefits we offer are fast service, free tech support, free software, fast shipping, and warranty. Energy is not an unlimited resource. There is only so much coal, natural gas, and petroleum. Use of petroleum products leads to environmental pollution from accidents in the mining of products, as well as air pollution from their combustion. In most parts of the country, wind and sun can't always be counted on for continuous power production. And the scarcer a resource is, the greater the competition for its use, and the higher the cost. Next generation heat pumps on our building roofs. We can add to our available power by installing solar panels and windmills, and we can use batteries to hold that power for later use. We can look at more efficient brushless motors when you want to run a conveyor belt. There are many actions that can be taken to reduce power usage. These are only a few examples. To lower operational costs and make our energy consumption more efficient, first we need to look at where we are in terms of energy consumption. And we have a wide array of smart power meters that can be used for this task. Smart power meters are used to help monitor energy consumption and save on unnecessary costs. The ICP DAS USA smart meters can be applied to low, medium, and high voltage to read energy consumption of your data equipment. They communicate over Modbus RTU, Modbus TCP, CAN bus protocol, and they're easy to integrate. It's very easy to integrate these power meters with SCADA software like InduSoft or Aviva Edge Web Studio that can be used for further control and analysis. Our power meters are compact and low in cost and come in 3-phase, single-phase, or multi-circuit measurement configurations. Our smart power meters form the perfect base for any industrial power monitoring system. And you can use our power meter concentrators to log and store and display live and historic power consumption data. Logging data is made easy by using a power meter concentrator like the PMC 5231. It can be connected up to like 24 Modbus power meters. It's flexible so that you can easily add and remove power meters. The software includes real-time and historic data logging with display and inquiry functions. It can generate a wide range of analysis reports through a web page that can be accessed via a PC or a mobile device. So no matter where you are in the world, you see how your factory is doing. Power meter concentrators with display. We have the PMD 2201. It has all the benefits of a power meter concentrator, and with the addition of a 7-inch touchscreen display for on-site system configuration and on-site display of your power data. It can be set up to automatically transmit your data files, and you have the ability to recover the files in the event of a network disconnection once your communications has been restored. It has the ability to do if then else logic, just like our WISE controllers. It gives you the ability to manage your power demands through schedule and timer functions for I/O module operations, and you can send alarm notifications. Here's a table comparing a power meter concentrator with a power meter concentrator with a display. Both give you even more functionality than I've mentioned so far. Once you've gathered the information on your present energy usage, that's when you can begin optimizing your resource utilization. Optimizing resource utilization means making the most use of what you have. Once you've installed your power meter concentrator and analyzed the loads that you're placing on the power grid, you will know the amount of power needed for your production runs. You can use predictive analysis to adjust your production schedule to utilize the power grid at less expensive times, and that will cut your production costs. The definition of predictive analytics is the use of data to predict the future trends and events. Historical data is used to make assumptions about the future. Predictive analytics can be used for preventive machine maintenance scheduling. You need to understand the life expectancy of the parts of your system so that you can replace unnecessary machine parts before they die. This is important to prevent your costly shutdowns, and it reduces your maintenance costs and it increases your product production. By measuring the temperature of key components in each machine, such as your motors, heaters, bearings, valves, and pumps, to see if the temperature has increased, and measuring whether the current for each component has changed. Increased temperature and a change of current usage can be signs that maintenance should be scheduled to avoid any risk of financial loss due to unexpected shutdowns. The PET 7H16M module is ideal for high-speed data acquisition. ICP provides smart predictive maintenance solutions to enhance the efficiency and transparency of equipment monitoring. The PET 7H16M module includes 8 high-speed analog input channels with a maximum sampling rate of 200K samples per second, which allows for simultaneous 16-bit analog to digital signal conversion on each channel. This makes it suitable for high-speed data acquisition from a variety of mechanical, electronical, and physical signals in various fields such as your industrial production, automatic control, electrochemistry, medicine, etc. The PT7H16M can use its Ethernet port to transfer data over a network. We also provide a utility that can be installed on the host PC, which not only supports Visual C, C#, and VB.NET API, but also LabVIEW development tools, meaning you can easily manage data using these tools. Using the PET 7H16M with one of the SG 3000 series modules lets you connect to a variety of sensors for current, voltage, thermocouples, resistance to temperature detectors, and strain gauges. These signals can be filtered or amplified and converted to an analog or current output in a common measurement range. The D&M 800 series is a voltage attenuator and current transformer designed for use in high voltage applications. The current can be converted into a plus or minus 10 volt peak-to-peak attenuated signal so that a general electronic measuring device is able to read the signals. Using a DM800 series module in conjunction with the PET7H16M will get you the power meter data from all kinds of machines. The current and voltage of AC and DC motors can be easily measured and retrieved. Then the analyzed data can be used to develop a model to build a failure warning system. A palm oil machine is made up of an oil pressing screw and the motor that runs it. If a machine is overfed with palm kernels, the processing speed of the screw is going to slow down due to the adhesive kernel material that's stuck on the screw. And when this happens, power consumption will increase sharply. Operators have to spread those palm kernel seeds very evenly in the feeder to prevent a slowdown. And this does not always happen, and it can cause premature aging of the system. To acquire power consumption data on the motors, three-phase smart power meters like the PM3133-360P together with Internet of Things power meter concentrator 5231M were used. The Modbus TCP protocol, the information on the motors was using the Modbus TCP protocol. Information on the motors was sent to the SCADA system. Analyzing the data, they were able to see which of the machines had been operating under a high load and schedule maintenance on those machines. This prevented time loss due to breakdowns and increased the mill's productivity by 28%. ICP DUS believes that our mature electric power measurement series of products are the best choices for those involved in the industry. They will help you to understand the needs of your systems from a practical point of view, whether the source of your needs is the origin of power, such as the monitoring of power generation efficiency and power quality of power plants, or whether the source is in real-time monitoring of data related to wind turbines from an offshore wind farm, or the monitoring of green energy from solar power generation systems, or the acquisition of other data related to electric power and more. You can create a monitoring system that provides scalability, expandability, and high stability to monitor wind power generation, solar power generation, and energy storage using CAN bus protocol, which is highly fault tolerant and fault detectable. With a battery information concentrator like our VP1231CE and a battery cabinet management platform like our XP8341. The world's largest battery energy storage station at present is the Zhangbi National Wind and Solar Energy Storage Transmission Demonstration Project. This project in Zhangbi, Hebei province in China, has implemented the world's first ever technical route for wind and solar energy and transmission. The model is a new energy demonstration project that integrates wind power, photovoltaic cells, energy storage devices, and power transmission. By taking into account the instability of wind and solar power generation and the high and low peak times for power consumption from the grid into consideration, any redundant power can be stored when the power generation capacity is greatest, or during the low usage period from 7 p.m. to 7 a.m., any power energy previously stored in the storage data station can then be fed back onto the grid to supplement the gap in power demand and solve any problems related to power demand that may arise where low power generation or peak power consumption occurs during like peak usage from 10 a.m. to 3 p.m. Severe environment, as the daily average temperatures in Hebei province, China, is less than 0 degrees Celsius for more than half of the year. It's particularly important for the battery management system to be able to perform robustly and remain stable under high temperature and low temperature conditions, no matter whether it's subject to a temperature shock of minus 30 C or up to 85 C, whether it's installed at a high altitude of more than 4,000 meters. Complex communication technology. The battery management unit, which was developed by the customer, monitors the charging status and the health status and storage capacity, the battery temperature, the charging currents, and other information from multiple battery packs with the view of achieving the management of every single battery cabinet. The provision of data from multiple battery cabinets for subsequent power feeding and energy storage operations, and the transmission of battery status and energy storage status from each battery pack to the remote monitoring center. Each group of systems includes a battery cabinet management platform under which a maximum of 12 battery information concentrators can be connected. Each battery information concentrator can be connected to a maximum of 8 battery units. The system architecture is shown to the left. ICP DAS's WISE series to Internet of Things edge controllers collects data from solar power plants located in Phuket, Thailand, and its surrounding 32 outlying islands. The data is then transmitted to a control center in Phuket via 4G wireless connection and managed with the IOStar software that was developed by ICP DAS. The software can easily monitor and manage the status of solar power plants remotely and displaying the data on the dashboard and providing the management personnel with an indicator of preventative maintenance for their solar power plants. Using Aviva Edge, you can graphically display the real-time power generation of your wind turbines and control the direction of the turbines in the wind to generate the most power. You can monitor the present battery storage levels in addition to the present levels of power consumption to help schedule maintenance and production runs. Aviva Edge is very flexible. It can be used to create dashboards for many different applications. Here's an example of monitoring a solar farm. ICP DAS-IO can be used in controlling the direction of the solar panels to follow the arc of the sun in order to generate the most solar power possible. ICP DAS's various energy management products have been used successfully worldwide. One project is in a country wide electric vehicle charging pilot program. In order to improve efficiency so that humans would not need to physically go to the EV charging stations to periodically check on them, they adopted the ICP charging station monitoring system so that all the stations could be remotely monitored, thus only sending out a technician when there actually was a problem. Using products like a pair of the ICP DAS I-2533 CAN to multimode fiber bridges prevents electromagnetic noise susceptibility of the data by converting the data from CAN to send it over fiber optics. It's converted back to CAN by the second I-2533, and it's sent to the piezo CAN 200U-T PCI card, which handles arbitration, error detections, and automatic error troubleshooting, as well as data transmission. Using our state-of-the-art technology, our customer was able to remotely manage a whole country full of electric vehicle charging stations with efficiency at a cost savings by reducing the need for manual viewing of the stations. The largest contact lens manufacturer in Taiwan uses computer control in the manufacturing of its contact lenses. They wanted to record and analyze their production equipment's capacity to improve their energy savings, and IPC DAS came up with a solution for them. ICP DAS uses the isolated three-phase smart power meter PM3133I 160P to collect the factory's power information, and the DL100 TM 485P is used to monitor and record the temperature, humidity, and the dust in the clean rooms. The DL1020 is used to monitor and record the temperature and humidity of the production lines. The power meter concentrator, PMC 5231, is used to transmit all this data to the control center via Modbus TCP over its Ethernet port. So the factory workers can see the information on the factory floor. They use ICANN 124 industrial LED display to see the factory floor data. From this webinar, you can see the ICP DAS has a variety of smart power meters for any application and power data concentrator that can log environmental data in addition to power data. Fiber optics can be used to transmit that data without errors due to noise over long distances. Remotely logging data can increase efficiency by removing the need for manual data recording at remote sites. Okay, for our demonstration today, that includes the presentation. Okay, go over here. Okay, all right. Shut this down. Okay. So for our demonstration, I wanted to give you a view of one of our power meters. Here's the power meter. It's the 3112. And basically I have it connected right now up to a voltage source, and you can see that the voltage going to it is 112 volts, and you can see the current that it's measuring. It automatically gives you information on kilowatts, kVAR, and kVA, and power factor. Down at the bottom, you can see where you've got your kilowatt hours and kVAR-H and kVAH. And you can see that the frequency of the power is at 60 hertz pretty much, which is what you'd expect. If I turn off my load, you can see that the values are going to go drop down to 0 on the current. So there's no current being drawn out by the load right now. Turn it back on, the current comes back. Now I have hooked up to the power meter. I have the PMC 5151 power meter concentrator. And let me go back to there. All right. Okay, not right now. Close that down. So here's the power meter display. You basically type in the URL, basically the IP address that you set up, give it a password, and then you're going to have the opportunity to set up whether you want under system settings. If you were going into any power meters that were over Modbus RTU, you've got your two COM2 and COM3 to set up. Right now, then you also have the option of Modbus TCP, and the power meter that I was just showing you data from is the power meter that's over a Modbus TCP. So for my main page, so you basically would go under a module meter setting, you would go down and scroll down, and you'd basically click on this. There's a little plus sign, you type in the meter identification information, and then you save it, and then you load it onto the power meter. And once you've got that done, then you can go back and use it on the main page. You can go down and check out how we're doing on historic chart that's been recording for a little bit. So right now I had it set up to record power over a minute. I've got it set up to do average. So you can see what our voltage is up here on our little chart. And it's basically monitoring the voltage going through my current transformer. Okay. So you can do a historical chart, you can do real time as well. And there's our real time spots at the moment. So as you're sitting here, it'll just slowly start going across the screen. And you basically install a little micro SD memory card, and that will store all your data. And you can actually come here and see it live by logging into the URL. So that's pretty much our presentation for today. Thank you very much for attending. I hope you have a wonderful week, and let us know if there's any products that we can help you with.